So we've been starting to look at rate of change, the difference between the average rate of change and the instantaneous rate of change. And so let's look at an example where we have a cubic function and we want to find the instantaneous rate of change of this function f of x equals 2x cubed plus 5 at x equals -2. And so recall, when we're looking for the instantaneous rate of change at a particular value, we're looking at the limit as h approaches 0 of f of, so it depends on what value we want to look at. In this case, our x value is -2. Usually we put a plus h, but our a value in this case is -2. So -2 plus h minus f of a. But again, our case, our a value is -2, so f of -2. And then we put this all over h. And so now looking at this, we're going to go back in, and wherever we see an x in our function f of x, let's do this piece, this first piece in our numerator, f of -2 plus h. So let's bring down our limit. I'm going to bring it over here so I have more room. And we're plugging in, I have a 2. I see an x here, so let's just put parentheses for now and we'll go back in. Enough room to plug in that whole expression, -2 plus h, cube it, plus 5. Let's plug in -2 plus h. And then we have minus, oops, sorry, we still have here plus, and the 5, okay, minus f of -2. So again, wherever we see an x in this function, we're going to put parentheses, and then this time we're going to replace it with the -2. And so here we have parentheses. I see a 2 here, so put 2. I see an x, so parentheses cubed plus 5. And then we're putting this whole thing all over h. Okay, so we have some expanding to do and distributing and combining like terms. And so we can either do this right here, we can do it on the side. You just need to be careful that you're not right here. I cannot distribute. Whoops. I just downloaded something. I was trying to meet you guys. I don't know what I downloaded. Anyways, sorry, sidetracked. Just be careful here. You cannot distribute this 2 inside the parentheses here because of this cubic outside. And so remember, order of operations, we work inside the parentheses, can't combine anything here. Then we go to exponents. So we need to expand this -2 plus h times -2 plus h times -2 plus h. Maybe we can do that work on the side because it gets a little long and could get kind of nasty. So let's look at this. So -2 plus h, quantity cubed, is telling us we're taking what's inside that parentheses and multiplying it by itself 3 times. So let's first start with the first 2 parentheses and do our distribute. So -2 times -2, that gives us 4. -2 times h, this is -2h. We have an h times a -2, so -2h, and h times h, so plus h squared. Let's keep our parentheses around that, and then let's bring down, so we don't forget about it, the -2 plus h. I'm going to just clean up what's inside my first parentheses by combining these like terms, and I'm going to rewrite it in descending order of powers. You don't need to do this, but it's just helpful for me. So h squared, -2h plus -2h. That's minus 4h. Then we have this positive 4 here. And then we're going to multiply this all times -2 plus h. So let's distribute each term in the first parentheses to each term in the second parentheses. So h squared times -2 is -2h squared. H squared times this h gives me plus h cubed. So now if I distribute -4h to each term, -4h times -2, that's plus 8h. And -4h times h, this is minus 4h squared. And then one more term that we have to distribute is this plus 4. So distributing the plus 4 to each term, we got plus 4 times negative 2 is negative 8, and 4 times h gives us plus 4h. So let's just, again, rewrite this. I'm going to rewrite it in descending order of powers. So far we have no other term with a cube. So we have an h cubed. Looking at all my squares, I have a negative 2h squared minus a 4h squared is minus 6h squared. Did I miss one? No, I didn't. And now let's look at adding 8h plus 4h. Looks like. So 8h plus 4h gives us plus 12h. And then we have this constant here, minus 8 left. So let's bring that down. Okay, that was just the cube piece, right? We also have this 2 outside here. And so if we want to do that now too, we can say, okay, well, let's look at what is 2 times this negative 2 plus h quantity cubed. Well, that would have been 2 times what we just found, h cubed plus minus 6h squared plus 12h minus 8. So if we distribute that 2 to every term, we got 2h cubed. 2 times negative 6h squared is minus 12h squared. 2 times 12h is plus 24h. And 2 times negative 8 is minus 16. Okay, so this is just this piece now. And then we have that plus 5. So let's start bringing things down. So limit it as h goes to 0. And let's plug in this 2 times that quantity, negative 2 plus h cubed. So we found that that was 2h cubed minus 12h squared plus 24h minus 16. Then we have that plus 5 still. Minus, and so maybe we can go in here in this parentheses and do order of operations and simplify. So we have 2 times negative 2 quantity cubed. So the cube comes first. And so that would give me 2 times, well, negative 2 quantity cubed is negative 8. And then I'm going to add 5. Multiplication comes before addition. So 2 times negative 8 is negative 16. And then add 5. Negative 16 plus 5 is negative 11. So minus 11. So that was just this. And then we're going to put it all over h. So again, we can simplify inside or in our numerator by combining like terms. Excuse me. So let's do that. We have 2h cubed minus 12h squared plus 24h. So we have negative 16 plus 5. Oops, something's wrong. I know what's wrong. And this is a good thing I did it wrong. We forgot about this minus here. This was minus this negative 11. So minus the negative 11 is actually a plus. So that should be a plus there, plus 11. So negative 16 plus 5 is negative 11 plus 11. This gives us 0. So I knew really that my constants were going to cancel out. And so that's how I knew something was wrong. So limit as h goes to 0. Notice that we all have a factor of h in the numerator that we can pull it out, and then we can cancel it with a 1 in the denominator. So doing that, pulling out an h, we're left with 2h cubed, 2h squared minus 12h plus 24, all over h. So simplifying, we get the following. And so if we look at this, as the limit is approaching 0, now we can go do our direct substitution. So if we go in here and we plug in 0, wherever we see an h, we get 2 times 0 squared minus 12 times 0 plus 24. And so we're left with 24. So the instantaneous rate of change on the function f of x equals 2x cubed plus 5 at x equals -2 is equal to 24. So would anyone explain what's going on at x equals -2 on that graph of that function with what our answer is telling us? So we were looking at the instantaneous rate of change. We have a cubic function. Remember the rate of change, this is like the slope, what was happening on the graph, the slope at that x equals -2. So recall when your slope is positive, we know that our line is increasing, or graph is increasing. So it's going up from left to right. So we know that our function is increasing at that point. And then we're going to learn some more tools of finding concavity, but we haven't even talked about derivatives yet, but finding derivatives and finding other things about the function so that we can put these pieces together and be able to graph them without just plotting points or using technology.